All right, so this next section deals with the absolute value. And here we have the absolute value of 5, which is 5. Absolute value, these symbols, mean how far from 0. And so if you had, like, say, the absolute value of a -3, that answer is 3 because it's 3 away from 0. Now, when you have the absolute value of x, and that equals some number, let's say 4, then that means x could be +4 or -4. Actually, we should say and. Because both 4 and a -4 are 4 away from 0. So if you look at this statement here and then that one, when you get rid of the absolute value symbol, this number here turns into both the positive and the negative of it, providing that this is a positive number or 0 to begin with. Because if you had something like, what is the absolute value of x equals a -2? Well, there is no distance of a -2 from 0, so that means that this would be a no solution type of thing. All right, so then moving on. If we were going to solve an equation dealing with 2x plus 4, and the absolute value of it equals 10, because the absolute value is around this whole entire expression, you first have to get rid of the absolute value symbols to have 2x plus 4 equals 10 and -10. Now that's one way to write it. And so now we would solve for x by subtracting 4, and we have to subtract from 4 from both 10 and -10 to get 2x equals 6 and -14. And finally, then you divide by 2 to get x equals 3 and -7. Now, this is one way to have it written. The other way to do this when you get rid of the absolute value symbols is to write 2x plus 4 equals plus and minus 10 like so. The problem with writing it like this is people will make this mistake and they will subtract 4 and say 2x is equal to plus and minus 6. And that is not correct for half of it because the positive 10 minus 4 is 6, but a -10 minus 4 is a -14. So if you do write it like this, that's okay, but just don't make that critical mistake. Then another way to write this is to put a -10 is equal to 2x plus 4 is equal to 10. Whatever this value is, you just move it to this side and put a -10 there and use the same symbol. That will come into play later. All right, so let's move on to this one. Here we have a 3 times the absolute value of x minus 2. So the first thing we'd want to do here is divide by 3. Now we have the absolute value of x minus 2. Wow, that's just not good writing. X minus 2 there equals 5. And then from this, you can get rid of the absolute value symbols and get x minus 2 equals 5 and a -5. And now add 2, and x will equal 7 and a -3. Then moving on to an inequality, kind of the same type of thing. If this were an equal sign here, then you would say x equals 4 and negative 4, or x equals 4 and negative 4, like that. Well, when it's an inequality, it's the same concept. The only difference being this value here has to be greater than 4, because if it is 3, it doesn't work because the absolute value of 3 is not greater than 4. But then it also has to be less than a negative 4, because you can't use a negative 3 in here or a negative 2, but a negative 5 could be. So look at this statement compared to what's here. Yeah, it's the same thing without the absolute value symbols. But this statement is not the same as this. This number is the opposite of that one, and the symbol is the opposite of that one. So in an inequality, when you get rid of the absolute value symbols, that part stays the same. And then the other one, you switch the inequality and you switch the sign. The other way that you can write this is to just drop the absolute value symbols, x is greater than 4, and then just leave the symbol pointing in the same direction and put a negative 4 here. That says the same thing as that. Now, if you have something like the absolute value of x is greater than a negative 2, well, anything you put into here is going to be greater than negative 2, so this would be all real numbers. Would work. Okay, so then looking at this problem. First thing we'd have to get rid of is the absolute value symbol, so then we would have 3 times x minus 2 less than or equal to 5 and greater than or equal to a negative 5. And now you can distribute the 3 next, or you can divide by 3, either way. So 3x minus 6 is less than or equal to 5 and negative 5. And then we can add 6. And then you're going to get 1 is less than or equal to 3x, which is less than or equal to 11. And finally, you divide by 3 to get a final answer of 1/3 and 11/3. So on a number line, let's put 1/3 right here and 11/3 right there. And because it's less than or equal to, we would have a closed circle at both spots. And we have to be x is less than or equal to 11/3, so we're going in that direction. And x is greater than or equal to 1/3, so we're going in that direction. So we're just connecting. So all the values between 11/3 and 1/3 would be solutions to this equation, including 1/3 and 11/3. And then the other thing about this problem would be is if this is just less than, well then you're going to have just less than down here and greater than down here, and so then you would have open circles at those two spots. And then the final thing to remember is if this turns into a negative number here, that is a negative, then when you divide by a negative number in an inequality, it would flip the sign of the inequality. Okay, and that is everything for this section. And so in Schoology, you should have some problems that are highlighted to do.